Lesson 7 assignment. There are 5 questions. I'll review 3 of those questions today. And our goal is to apply the concepts of surface area and volume to a 3D object to determine its cost. Just a reminder, when you're calculating cost, unless it's stated taxes included, you'll have to calculate the taxes, and there are 2 taxes in Manitoba. The PST, the provincial sales tax, is 7%, and the GST is 5%, goods and services tax. Altogether, it's 12%. You will need also your formula sheet for reference. You need so have this handy, and you'll need a calculator. Let's look at the first question. An outdoor supply company wants to manufacture tents that are in the shape of a triangular prism. So they only tell you the figure or the type of prism in this triangular prism, and the dimensions are given below. Now, it's not drawn to scale. And the question is, calculate the amount of fabric to make a tent. Now, when you're looking at a tent, there's fabric all around it, on the floor, the bottom here, the sides, the front and the back. So there's nothing left open. So we're looking at a total shape. Nothing is excluded in this tent. Now, in the triangular prism, so we're looking here for surface area. Finding the surface area of this tent. That's for part A. And part B, once we determine the surface area of the tent, we then can calculate the costs of the fabric to make a tent. Since they give us what kind of figure it is, a triangular prism, and they're asking you the amount of fabric, so this will be the surface area of the triangular prism. So now we go to our formula sheet, and the surface area is the base times its height. Remember, it's the vertical height, plus L, which is the length, right? Plus the slant height here, A and C, their slant height, plus B, the base. Think of this as a triangle. So this would be a right angle triangle with a hypotenuse, so I put a slant height, so C. So record our formula. So part A, to find the surface area of the tent, use formula. Oops. So we're going to use triangular prism formula. Which is base times the height plus the length, A plus B plus C. Our next task is to determine A, B, C, and L, and also the height. So if you look at our figure, we'll see that this is the A. Now, because this is 50, slant here, this is also going to be 50, and this is B. Well, this would be C, which is 50 inches and 50. So now we have our length. We have, this will be referred to as B, and this is C. And this would be H. So we can record that A is equal to 50 inches, B is equal to 50 inches, C is also 50. H is 43.3. And L is 80 inches. To find the surface area now, I'll replace B with 50 inches, H with 43.8, L with 80, A, B, and C 50 each. Let's go ahead and do that. So we have 50 times 43.3 is our height. Our length is 80. Multiply by 50 plus 50 plus 50. Now we got a good old calculator out here, and we're going to do some calculation here. So you have 50 times 43.3. It was 2165. 2165, and that'll be in square inches. And you go ahead and find the AD. Now I'll use my brackets exactly here, and I can do this plus 50 plus 50, close bracket. This will give me 12,000 square inches. Now add the two measurements plus 2165. So the total surface area, or the amount of fabric you'll need, would be 14,165 square inches. So the amount of fabric for the tent. So that's the amount of fabric. So we can highlight that. Amount of fabric. So that's for A. B asks you if the tent fabric costs $0.01 or 1 cent per square inch plus tax. So we have to add our 12% tax. Determine the cost to manufacture one tent. Now, we found the amount of area or fabric you'll need to make one tent. Now, that'd be 14,165 square inches. Find how much this will cost now. It tells us it's 0.01 per square inch. So we'll multiply the area or the amount of material for the fabric by 0.01 to give us the cost or the price we'd have to pay the merchant. Then you have to add 12% tax to that amount. So we can say the cost of material or cost of fabric would be amount of fabric multiply by 0.01 plus your taxes. I should put here 12% taxes, so be specific. The amount of fabric we discovered is 14,165, so 14,000. So this will give us what? Let's work that out. So 14,165 times 0.01, 141.65 now plus 12% tax, which works out to be 141. You see $158.65. So the cost to make 1 tent. The next question, 2. You want to build your nephew a new toy box. The box is going to have no lid. So you have no lid here. And it will measure 6 inches by 3 inches by 2 inches. And here's an illustration of it. You have the height. So we can say this is the height. This would be your length. And this is your width. So they have no lid. So question A, how much wood would be required to build the box? So how much wood refers to surface area? How much surface area you have? So we can put here much. So we're going to find the surface area. Now it is rectangular prism, as it's called, or a solid, rectangular solid. So we need to find the surface area. So the surface area is 2 times length times width. Now this is for all 6 sides. So this will be the top and the bottom, but there's no top in this example here. So we'll have to adjust our formula. This is the front and the back, and this is your ends. So surface area, let's record that. amount of wood is referred to the surface area of the box with no lid. So surface area for a box, we know it's the 2 times, I'll record it here, 2 times length times width plus 2 times length plus height plus 2 times width times height. I'm just going back to my formula here. Now, this is for the top and the bottom. Since there's no top or bottom, we're going to remove to make it 1. Okay. Now we need to find for the surface here. So we need to know the dimensions. It's given here. So our height is 3. So let's record it to the side here. So the height is 3 feet, or width is 2 feet, and our length is given as 6 feet. Now I'll substitute these values into our formula. So you have length is 6 multiplied by the width, which is 2, plus 2 multiplied by the length, which is 6 times the height, which is 3, plus 2 multiplied the width, which is 2 multiplied by the height, which is 3. This works out to be 12 plus, let's record this feet here. This will give us 36 square feet plus 12 square feet. So the total amount of wood that is equal to 6 square feet. So we'll highlight that because we'll be using this again. Now, B, what is the volume? So I'll put a line across here. For question B, or part B, what is the volume of a toy box that the box can hold? So volume, that B here, volume of a box, and is equal to length times width times height. We go back to our formula sheet again. Rectangular solid, length times width times height. We have our length is 6 feet, our width is 2 feet, and the height is 3 feet. And this gives us 36 square feet, or be cubic feet. 36 to 16, 12, 36 cubic feet. So volume of the box for C, if the wood to build a box costs $3.75 per square foot plus tax, what would be the cost of the wood to build this box after tax? So the cost of the wood would be, the cost of the box, or the cost of the wood to build the box would be the surface area of the box, and we already have it in square feet, multiplied by the cost per square foot plus 12% tax. Okay, so here's our cost. We're going to take our surface area multiplied by the cost per square foot. As long as you have consistent unit, we don't have to do any conversion, plus your 12% tax. So C so cost would be surface area of box multiplied by, that was $3 and this is given here, $3.75 per square foot. Plus 12% taxes. And we know the surface area is 60 square feet. We have 60 multiplied by so we do our calculation here. What do we get here? So we have 3.75 times 6G. Give us $225. Now we're going to multiply by 1.12 to get our taxes for the total price. $252. So the cost would $252. So let's see B and then A. Part D, you're going to protect the outer surface of this box with varnish, which is a clear type of paint. A small can of varnish covers 30 square feet and costs $13.57 plus tax. So each can of varnish costs $13.57. Calculate the cost of the varnish for this toy after tax. So remember, you're buying cans of varnish. So if it's not exactly 1 can or 2 cans in your calculation, you need to round up to a whole number. This is discrete. So it's D. So the cost of varnish so tell us if 1 small can, covers 30 square feet. So to find the cost of garden would be number of cans of varnish. So we need to know the number of cans and multiply by $13.57 plus 12% tax. So we need to calculate a number of cans of varnish. So number cans of varnish will be the surface area divided by 30, because this tells you how much one small can of varnish will cover. How much surface area of wood will it cover? So the number of cans of varnish is equal to surface area of the wood in this case the box. So we can see here surface area of the box times 1357 plus 12% tax. So we know the surface area is 6 square feet. Sorry, the number of cans would be divided by, okay, this is wrong, change this. So we would divide it by 30 square feet. I'm jumping the gun trying to find this cost. So this will give me 2 cans. Actually 2 cans exactly. So no rounding here. So number of cans. So we can finally cost of varnish is equal to 2 cans multiplied by 1357. So let's work that out. So 2 times 13.57 give us $27.14 multiplied by 1.12. $30.40. So the cost of varnish so $30.40. The final part E, state 2 other costs you might incur in making the box. Well, it could be the type of wood, because the cost of wood varies depending on the type of wood you purchase, and also type of varnish. So there are multiple answers for these. Possible answers you can have here. Would be the type of varnish. Because they're deluxe, there's some easy to clean, etc., more long lasting, or the kind of type of wood. What's the type of wood? You can buy pressure-treated wood, which may cost more depending on the type of wood you purchase. So these are possible answers. Other answers are possible, but these are two possible answers. Here we're looking at a ice cream cones, and we're trying to find out how many cones could be produced when you're given a certain amount of batter. So let's look at the detail of the question. So Marcus Foods and Distributors is a food manufacturer in Canada that specializes in making ice cream cones. They make waffle cones. There's one here across here that has a diameter of 8 centimeters. So we have the diameter here is 8 cm. So you can write it here, diameter of 8 centimeters, therefore the radius would be 4 centimeters. Has a slant height of 12 centimeters, so the slant height, so we get our L, slant height is 12 centimeters. Okay, so that's our L. Now, to make the cones, first make batter. Like each batter can make 20,122 centimeters square of baked cones. How many cones can be produced? Now, the number of cones can be produced is the amount of batter divided by the surface area of a cone. So we need to find the surface area of one cone, because the surface area will tell us how much batter you need to make one cone. So step one, find how much batter to make one cone. And then to find how many cones you can make, you take the amount of batter in one batch and divide it by the surface area of the one cone. Okay. So to find how many cones produced, so overall, what we'll be doing here to find how many cones can be made from one batch of batter. One batch of batter has 20,922,000 square centimeter. Step one, find surface area, or how much batter needs to make one. How much batter, which is the surface area. Find how much batter to make one cone. Then we will divide the number of batter in one batch by the surface area of one cone. So let's find the surface area of a cone, of this cone. Now, we'll have to use our formula. Now, the surface area of a cone is 2 times pi times the slant height plus pi r squared. Now, this is when you have a lid, but there's no lid in the cone. So we don't this that part because let's talk about the top of the cone, which is inside. Here's a circle. We don't have here, we don't have any lid there. It's open. So our formula then for the surface area of a cone be pi r times the slant height. So we know the radius and we know the slant height for a cone. So let's write that down, which is pi r L. So we know r is equal to 4. So pi times 4 times 12. This gives amount of batter now. So the amount of batter to make one cone is equal to, let's do that calculation here. Pi times 4 times 12. Give us 150.796. So we'll 150.7964. And it goes on. And that will be in square centimeters. So this is the amount of batter to make one cone. So how many cones? Okay. So one batch can make 20,922,000 square centimeter. So this is how much in one batch of batter. Just do one batch of batter here. So the number of cones is equal to 20,922,000. Too many zeros here. Divided by 150.7964. I'll use the actual number here. So that's, so we'll have 20,922,23 divided by my answer. Now, depending on your rounding, I'll use the exact figure in the calculator. But if you were to round up to 150.8, you'll have a slightly different answer. That's okay, depending on the rounding. I'm not rounding here. I'm using the exact values in the calculator. That worked out to be equal to 13,873 cones. So that's how many cones you can make from one batch of batter. So review your question. You already find the surface area, and there's no top. So the amount to make one cone, then we're given that to make one batch, that's 20,922,000 square centimeter. And to find how many cones that could manufacture, we divide the amount in one batch by the amount in one cone.